Hey everyone, welcome back. In this video, we'll be discussing about the fourth problem of today's weekly contest, maximum Xor Score Subarray queries. The problem is a bit difficult, and the difficulty of the problem lies in the fact that the problem requires you to make some observation, and not only that, even after making the observation, you need to uh, apply some algorithm to finally fit your solution in the given time constraint. So the video will also be focused or divided into two major parts. First, we will be focusing on decoding this two operations itself. That is, we will figure out how to apply these two operations efficiently. And after that, we will be focusing on how to figure out the Xor score of every subarray efficiently. So if you are interested in the specific section, you can, all the timestamps are there in the description down below. You can jump to the section of your choice as you wish. Having said that, would encourage you to watch the complete video to get a better understanding of how to approach these kind of problems in general. So with that, let's get started. The problem states that you're given an array nums of n integers and a 2D integer array queries. Each query, you have to figure out what is the maximum Xor score of a subarray, of any subarray of the nums L to R. Now, what is Xor score? Xor score of an array A is found by repeatedly applying the operation on A so that only one element remains, and that's the Xor score. What is the operation? Operation is you will replace AI with AI Xor AI plus 1 for all the I simultaneously. And after doing this operation, you will remove the last element of the array A. So at every iteration, you are removing one element from the array. So after some point, the array will be left with just one element, and that one element will be your Xor score. So you need to return the answer for every query in the given problem. So let's take an example. Let's say nums is this, and queries, there are three queries: 0, 2, 1, 4, 0, 5. So let's start with the first query. Now what you need to return is for any subarray of this length 0 to 2, in 0 to 2, you need to figure out which of them has the maximum Xor score. That will be your answer. So for example, in this case, 0, 2 has 6 different subarrays. 1 is 2, then 8, then 4, then 2, 8, 8, 4, and finally 2, 8, 4. So these are the 6 different subarrays of 0, 2. For each of them, you will figure out the Xor score. So Xor score of 2 is 2. Xor score of 8 is 8. Why? Because 8 is the only element, and that you can't apply this operation anymore, and that's why 8 is the Xor score of this array itself. Similarly, Xor score of 4 would be 4. Xor score of 2 and 8 would be 10. Why? Because you need to apply one operation here. The operation in that operation you will replace this with 2 Xor 8, and then you will remove this. So after doing the operation, there is just one element left, which is 10, and hence 10 is the Xor score. Similarly, you will apply the operation here, and after applying the operation, there is just one element left, which is 12, and hence 12 is the Xor score. And finally, 2, 8, 4, you will apply the operation twice here. After the first operation, this will be 10, and this element will be replaced by 12, and you will remove 4. So after that, you will have 10 and 12. So you will again apply the operation. 10 or 12 is 6, and you will remove 12 from that. So overall, you will be left with just one element, 6, and hence 6 is the Xor score. So these are the Xor score of different subarrays in the range 0 to 2, and among all of them, 12 has the highest value, and hence 12 is the answer for the given query 0 to 2. In the same fashion, you will figure out the value or the answer for this particular query and this query. This would come as 60 and 60, and this will be your final result. So hope the problem statement is clear. Now what's the brute force way to solve this? Again, you can simply simulate whatever is given in the problem statement. For a given range L to R, you can simply say, okay, I will find out all possible subarray of that in that range. So in this case, there are various subarrays. First is 4759, then 475, then 47, and then 4. These are all the subarrays starting at 4, right? And then you will figure out all the subarrays starting at 7, so 759, 75, and 7, and then all the subarrays starting at 5, which is 5, 9, and 5, and finally all the subarrays starting at 9, which is 9. So for all of these subarray, you will figure out the XOR score for each of them and then find which one has the maximum XOR score. So let's assume that this has the XOR score of A1, A2, and so on. This has XOR score of B1, B2, and so on. And this has XOR score of C1, C2, and so on. And this has XOR score of D1. So among all of these A, B, C, D, and C and D's, you will find the one which is the maximum value, and that will be your answer. So what is the overall time complexity of this entire algorithm? First, you are figuring out the XOR score, or first you are figuring out the subarray of how many subarrays are there in this range L to R. So there are total n square subarrays. For each subarray, you are trying to find out the XOR score. How to figure out XOR score? You have some elements. You apply XOR. So this 2 get merged to this one, this 2 get merged to this one, this 2 get merged to this, and this 2 get merged to this, and finally you will remove this one, right? Similarly, after this you will apply the same sort of operation, right? And after that you will apply the same sort of operation, and finally you will left with one operation. So what you're doing is, if you have n number of element, you are applying n minus 1 operation to get to n minus 1 elements, and then you are applying n minus 2 operation to get to n minus 2 elements. You are applying n minus 2 operation, and so on and so forth, and finally you get with one element. So overall you are applying 1 plus 2 plus all the way up to n minus 1 number of operation, which if you sum this up, that will come out to be n square, right? So, or rather x square, where x is the length of the original array, and in this case the length of the subarray in worst case can be n. So to figure out the XOR score of every subarray, you will need n square time. Now after you have done this operation, you have A1, A2, A3, A4, B1, B2, B3, C1, C2, and D1. You just need to take the maximum across all of them, and that will take you order n square time, because there are n square elements. You can simply iterate over them and get the maximum. So this is your overall time complexity. For simplicity, let's get rid of this because that's not required in the big O notation. So this is the overall time complexity, and this is for a single query. So you have q number of queries. So this is your overall time complexity for the entire q number of queries, which for sure will not pass because q itself is 10 power 5, and n is also 10 power 3. 2 into 10 power 3. So both n and q are big. Even n into q or n square q will not pass. N into q is something which we are aiming for. What does that mean? That means that you, even though you avoid iterating over all the subarrays, you still need to optimize for this part, which is like finding out the XOR score of a particular array. So it signifies that we should rather aim for finding out what is the XOR score of a subarray and try to figure that out in less than order n square time. Unless we can do this, no matter what else we do, the problem will not be solvable. So the smaller version of the problem that we are trying to aim for is, given a subarray, what it is XOR score in less than order n square time, right? So would encourage you to pause and try to think if you haven't already. So whenever these kind of questions are there, more often than not, there is some pattern involved. Now for this part, we'll not assume that there is pattern for now. We'll see when to kind of try to find the pattern, right? First of all, let's try to do a few iterations by hand. So if you do few iterations, you can see x1 XOR x2 is x1 XOR x2, x2 XOR x3 is x2 XOR x3, and after that you will do the XOR of these two. So x2 and x2, if you XOR this would make 0. So overall the XOR would be x1 XOR x3. So you can keep on doing this for 4 elements. It would be x1, x2, x3, x4. You can pause if you want to verify this. Similarly, for 5 elements, it is x1 XOR x5. For 6th element, it is x1 x2 x5 x6, and for 7 element, it is x1 x3 x5 x7, and finally for 8 element, it is x1 x2 x3 x4 x5 x6 x7 x8. Now there are two ways from here, right? One is you want to figure out the XOR score of every subarray efficiently. So XOR score for a single array, if you do it in the brute force manner, that will take you order n square time, and there are n square array. So this is your current time complexity. You need to optimize this. Now one of the way could be you are seeing that for a length x, if you know this expression, you can optimize this n power 4 easily, right? So let's assume that this expression is of length c, and c is some constant, right? If you can figure out this expression of c length, then what you can do is for every length of 4, you can iterate over the entire array, and for every 4 length subarray, you can simply look at this expression and figure out the XOR sum, right? So figuring out what is the XOR sum would be an order C operation for a single length subarray. So how many different lengths are there? N different lengths are possible. So overall complexity would be n square C. Again, assuming that you are, first of all, this C should be a constant one. If it is equals to n or something, this will not be of much use. And second, you are able to get to the C as well. Now to get to the C, you need order n square operation, right? You have to go through this entire thing, and this entire thing will take order n square time. So for a single length, you need order n square operation to get to this expression. So for n different lengths, you will need n cube operation to get to this entire thing. So overall complexity would be n square c plus n cube, which is fine, which is better than at least this one, given this c itself is smaller. But c actually is not smaller, because you can yourself see for a length of 2, the expression has 2 different variables. For length of 4, it has 4 different variables. For length of 8, it has 8 different variables. So you can imagine that for length of 16, it would have 16 different variables, and so on and so forth. So the c as well, is not particularly a constant one, it's also a variable. So this would also be n itself, and hence you can't do much better here, right? So that's the point where you should try to look for patterns, because now you have seen that for a single length you are not able to optimize. If you try to find out the value for a single subarray, there is no way you can get to this random expression, because you can see for length of 6 it is x1 x2 x5 x6, for length of 7 it is x1 x3 x5 x7. So you can't get to this random expressions without even going through this entire journey. So either there is some pattern which you figure out, or you can't optimize this, right? So we should now figure out if there is a pattern. More often than not, to figure out the pattern, you just take the first 8 elements and see, or try to make some observations here. So in this scenario, or rather in most of the scenarios, you will see things are mirror images of each other if you take it in the power of 2, right? So if you see, ideally, like if you have let's say you want to figure out the XOR values, or maybe the binary representation, you see that the things are mirror images of each other in powers of 2. So this 2 is kind of mirror image of this 4 is kind of mirror image of this, and similarly this 8 itself is a mirror image of the next 8 as well. So this is how usually you'll get the pattern whenever this like XOR or any binary operations are involved. So let's try to figure out, is these two somehow a mirror image of this, If yes, then we found the pattern, right? So think about it. What is happening? This is x1 and this is x1 XOR x3. So what is extra here is x3. X1 was there, x1 was there, so extra here is x3. So you can try to build some pattern, but let's wait for some time. Then for the next one, x1 XOR x2 was there, x1 XOR x2 is there, and extra is x1 XOR x3, x3 XOR x4, right? So there is some pattern, but it's not very clear. So let's move with one more iteration. Let's figure out if there's a pattern for this 4 elements or not. So this is x1, this is x1 XOR x5. Okay, so x1 is there, right? This is x1 XOR x2. This also has x1 XOR x2 along with some other things. This is x1 XOR x3. This also has x1 XOR x3 along with some other things. Finally, this is x1 x2 x3 x4. This also has x1 x2 x3 x4 along with some other things. So at this time, it is very evident that whatever is there in the previous value is occurring in the next one as well, along with something else. Now what is that something else? Again, you can try to pause and figure out by yourself, but if you notice, that something else is nothing but if you subtract the value with the nearest power of 2, whatever is that value, that's something else. For example, in this case, with x1 we had x3, which is nothing but 1 plus 2. Similarly, with x1 and x2 we have x3 and x4, which is nothing but 1 plus 2 3, 2 plus 2 4. In the same fashion, if you look at this one, with x1 we have x4, which is nothing but 1 plus 4. Similarly, with x1 x2 we have x5 x6, which is nothing but 1 plus 4 and 2 plus 4. Similarly, for x1 x3 you have x1 x3, and you can simply do plus 4, which is x5 x7 to get this 2. And finally, for x1 x3 x4 x1 x2 x3 x4, you can simply do plus 4, x5 x6 x7 x8. So that's basically the pattern. The pattern is, for a given length x, right, you will figure out the nearest power of 2. So let's say the nearest power of 2 is 2 power L. Just assume that. Now what will happen is, there are 2 power L number of elements before, and then there are another 2 power L number of elements below this, and within that there will be some x, right? And it will be going up to 2 power L plus 2 power L, right? Now we want to figure out this x. Now what is this x? As we have seen, this x would have the values that is there in the counterpart of this, along with some other values which is equal to the values here plus the 2 power L's there, right? So in other words, you can simply say whatever is the value here, XOR whatever is the value if you start your array here. Again, you can pause it and think about it for a moment. This x5 x7 is nothing but if you assume that your array is starting at x5. So this the third element of that array, or rather if you merge 3 elements there, you will get x5 and x7. So what you're saying is, the first 3 element starting at x1, and then 3 elements starting at x5. Whatever is the values for those two, if you sort them, you will get the value for x7 as well, or 7 elements as well. So similarly for this x, you will get whatever is the value here, and you will get whatever is the value for this part, and you can sort these two to get the value at x, right? So what is the pseudocode? The pseudocode would look something like this. you will figure out the nearest power of 2, right? And the value at starting at L all the way up to length would simply be everything starting at L with length minus nearest power of 2, right? Which is basically this part, right? Which is basically this part. And after that, you can simply assume that you are starting your journey from this number, and you can again figure out the value for same length to and sort them both to get the final value of score of L, score of the subarray starting at L and going up to all the way up, and is of length, right? So this is how you will figure out the Xor sum or the Xor score of every possible subarray in just order n square time. Okay. So again, this is nothing but an observation, which is the Xor value is nothing but the mirror image of the previous one, along with the first x values, assuming that 2 power L plus 1 is the starting point, right? So this is how we will figure out all the n square values. Now what you have at this stage is, for any given subarray of the original array, you have what is the Xor score. So for this one, you have what is the Xor score. For this one, you have what is the Xor score, and so on and so forth. So for every subarray, you have the Xor score. So if I just go back to the previous one, we can easily figure out this A1, A2, A3, A4, B1, B2, B3, and C and D in just order 1 operation. So overall, we had 4 n's here. First of all, we are iterating over every subarray, and then for each subarray, we are trying to find the Xor sum. Now this Xor sum we have pre-calculated before, and now figuring out the Xor sum is just an order 1 operation with an extra burden of order n square, which we have done before. So this is your new time complexity, which is order n square q. Again, I am dropping n square for simplicity, but this is your overall time complexity, which is also not sufficient because the value of q is very huge. Even as I mentioned, n into q is also very huge to pass, that might barely fit in the constraint, but for now n square q is not fitting. What does that mean? This means that even now you can't even iterate over all possible subarray here, and you need to do something better, right? So would encourage you to pause and try to think for a moment by yourself what exactly you can do from here. So hope you thought about it. The main thing that you should try to do here is see what exactly you need. So if you see that this is the subarray, or this is the L and R in the query, what you need is, what is the Xor sum of this one, what is the Xor sum of this, or Xor score of this, what is the Xor score of this, and what is the Xor score of this. Basically you need this 4 value and take maximum across all of them. Then similarly you will do this is like the Xor for everything starting at 0. This is the Xor for everything starting at 1, Xor for everything starting at 2, and so on and so forth. So basically, if this is the L, you need this value, this value, this value, this value, because this value will denote what is the Xor for this subarray. This value denote what is the Xor for this subarray. This value denote what is the Xor for this subarray, and similarly this value denote what is the Xor for this subarray. So you need max across these 4. This will cover all the subarrays starting at this particular L. Now you need max across these 3 as well, because this will cover all the subarrays starting at this L. Similarly, you need the max across these 2 as well, because this will cover everything starting here. And finally, you need the max of this as well. So all the ones which are ticked, you need max across all of them to get your final answer. Now, if you think about it, everything which is not present in these subarrays, they are like by definition 0, right? So what you indeed need is what is the maximum in this matrix, in this submatrix. And one more thing to note here is this submatrix would always start at the first column and always end at the last column. Like basically you can extend this submatrix to something like this as well. Like you can assume that this is instead of finding out the maximum across these values, you can simply find out the maximum across these values to get your final answer. Now, how to find out the maximum in a submatrix that start at the first column and also start at the first row? So would encourage, sorry, and also start at the last row. So would encourage you to pause and try to think for a moment by yourself. So note that let's forget about this 2D matrix for a time, and let's assume that you just need to figure out what is the maximum across these cells. How to do this? Simple, prefix sum, right? You can simply, instead of maintaining the actual values, you can maintain the prefix sum here, and you can simply say the value here would be the maximum across all of these. Similarly, the value here would be the maximum across all of these, value here maximum across all of these, and so on and so forth for everything. Now, once you have done this, basically you can simply take the maximum across all these values instead, and you can get whatever you wanted. So instead of iterating over n squared numbers, now if you do the prefix sum, you will simply iterate over n number of numbers, or to be accurate, number of rows here, number of columns here, to figure out what is the final value of your query. So you have reduced qn square to order qn by simply doing this prefix sum. Now, can you remove this n as well? Answer is yes. You can, again, what you want? You want the maximum across all of this. So let's assume that r is not this, but rather or let's say L is not this and rather L is this. So what you want? You want the maximum in this range. In other words, you want maximum across all these 4 values. So you see, previously you wanted maximum across all these 5 values. Now in another query you wanted maximum across all these 4, and similarly there can be another query where you need maximum across all these 3 and then maybe all these 2. So what you're saying is, at any given point of time, you would need maximum in a particular suffix or prefix, whatever you call it, of this particular column. So after figuring out the prefix max, you can also calculate the suffix max, but this time in the column wise direction. So if I just try to visualize, we had something like this. We figured out the prefix max in the row wise direction. So this particular cell now contain what is the maximum across all of these values. Similarly, this cell contains what is the maximum across all of these values, and so on and so forth. Now, once we have this, you can take suffix max as well, which basically means that this particular cell will contain what is the maximum across all of these, right? Similarly, this cell will contain what is the maximum across all of these. Now, what does that mean? This means that maximum across this, 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 and this. What was this? This was maximum across all of this. In other words, this was maximum across all of this. This was maximum across all of this. This was maximum across all of this. And this was maximum across all of this. And you're taking maximum across all of this, which means this value is maximum across this entire matrix itself. Similarly, if you look at some other value, let's say this value would be the maximum across all of these submatrix, because from this you will get everything here, from this you will get everything here, and because you are taking suffix max, you are getting max of everything here. So this entire matrix maximum is something present here. So for any query L and R, now you can simply go to that particular row. So for this L, this is the row, and that particular column, and this value would simply give you the answer, because this value is the maximum across this entire submatrix, which is exactly what you wanted, right? So just to reiterate the entire solution once, we started with the brute force manner, and we saw that okay, even if we remove every subarray from here, we will not be able to make the solution within the time constraint. So we have to figure out a way to optimize, or to quickly figure out what is the Xor score or Xor sum, whatever you call it. Now we try to apply some algorithm based on length, but that also doesn't help much, because it also goes up to n cube in best case, right? And n cube is something which we can't afford, because n is 10 power 2 into 10 power 3. So at that point we say that okay, either that's it, or there is some pattern which will help us reduce the time complexity even further. So we noticed some pattern, and with this pattern we were able to come up with a simple pseudocode that can give us what is the score of every subarray in just order n square time, right? And what was the observation was simply, for any given x, look at the mirror image of that with the nearest power of 2, take that particular value, and also take the value starting at the mirror image position, and just XOR these two to get the answer. So what is this? This is basically everything starting at L to the value which is at x, which is x minus nearest power of 2. So this is what the value is. And similarly, what is this? This is nothing but the same thing. If you have started at here, let's say this is L, and you are looking for this length, so that is something we would already have, because we are computing everything from backward, right? So we already have this, and we computed this just a while ago. We can simply XOR these two to get the final value of score of L and N, L at particular length. Now what we are saying is, we have theoretically value for XOR sum or XOR score for every subarray. That is, for subarray starting at 0 and ending at 0, this is the XOR value. Starting at 0, ending at 1, this is the XOR value. Starting at 0, ending at 2, this is the XOR value. Starting at 0, ending at 3, it is the XOR value, and so on and so forth. Similarly, starting at 1, ending at 1 is this is the XOR value. 1 to 2, this is the XOR. 1 to 3, this is the XOR, and so on and so forth. Now we simply said that okay, now that we are able to figure out the XOR value in just order 1 time, we can simply iterate over all possible subarray and answer the current query in just q into n square time. Now even this is not sufficient, so we thought of something better, and by just doing one simple prefix max approach, we were able to reduce this qn square to qn by just having like order n square over it before even starting answering the queries. So before starting the query, like you have already figured out this. Now before answering the queries, you can simply figure out the prefix max as well, which will take you order n square time, and then you can simply answer the query in just order q into n time. But even that was not sufficient, or rather that is on the edge of the complexity. So what we did, we made one more observation there, and we say that okay, it is almost equal to figuring out the XOR or the maximum in a particular submatrix, and the submatrix would always, one of the corner of the submatrix would always be the lower left cell. So with this information with us, we saw that we can simply maintain a suffix max as well, that can give us what is the total maximum in a given matrix that always start at bottom left, right? So we simply do we have already done this prefix maximums. We do one more suffix maximum here, and we get to this particular array. Now, whenever we get a query of L, R, we'll simply look at this particular value, and that will be our answer. So we can simply figure out the answer for every query in just order one time. So for all the Q queries, we can do order Q operation. Now notice that what we have done before this is order n square operation to figure out the XOR sum or XOR value. After that, order n square operation to figure out the prefix max, which is this particular matrix. And then another order n square operation to figure out the suffix max, which is this particular operation. And finally, for every query, we'll just simply need order one operation to figure out this. So overall complexity would be order Q plus n square, which is well within the given time constraint. So if you have watched this point, I would strongly encourage you to pause and try to code this entire thing by yourself. Next, we're looking at the code. The code is exactly what we discussed. We'll first figure out the XOR sum or XOR score, whatever that was called, I think XOR score, for the given matrix or for every subarray of the given matrix. Now, notice that this XOR score is a little bit different. It's not exactly submatrix, rather starting at L for this length, what is the XOR score, right? But we want the XOR score for every submatrix. So we can simply convert this XOR score into a sub array XOR score by simply converting the subarray into the length. So for example, if you want the subarray, the XOR score of subarray L to R, I can figure out the XOR score of subarray starting at L and of length 3, which is R minus L plus 1. So we simply did this. XOR score of R comma C is nothing but XOR score of starting at R with this particular length, right? Now after that, we first do the prefix maximum, which is the value of R comma C would simply be max of R comma C comma the previous one, which is R comma C minus 1. After that, we do suffix maximum, which is value of R comma C. R comma C is nothing but the value of R comma C and maximum of R comma C and R plus 1 comma C. Column is same, row is increasing. Maximum of R plus 1 comma C. At this state, the suffix array contain the maximum of a particular submatrix that is starting at bottom left and ending at current cell. So for each query, we can simply look at that value to get our final result. So that's it. If you have any questions, feel free to post them in the comment section below. I would be happy to answer. If you like the video, give it a thumbs up and do subscribe if you haven't already. I will see you in the next one. Thank you.